All right, it looks like I'm going to be doing another tutorial live and blundering through it. Jared Landers using R for Q, GIS and Mapping, and I think the first thing that I need to do is get the city bike stations, separated values file. So there it is. How do I get it? I guess that's the path. Maybe I can just use the path. Maybe I need to download it. Let me see if I can download. There's the download. And there's the city bike station thing. So let me copy that and bring it into, I'm going to cut it from here, and I'm going to go to my GIS for climate tutorial and into my folder for R, my RStudio folder. I'm going to create a folder for it. I'm going to call it the city bikes tutorial, and then inside there I'll paste that. And I'm going to grab this and copy the path, come to here and close this instance. I don't need to save it. I should have another instance. There's my other instance right there, and I can close that. All right, so this is going to be called, keeps drawing. I don't want it to draw. I don't need it to draw. I'll call this one the City Bikes tutorial. I'll call it City Bikes tutorial. And this looks like it just keeps plotting the older plots that I have. Yes, I know. Keep plotting. I don't want to plot this. Why are you keep plotting for me? I keep getting rid of it. Get rid of it. Get rid of it. Removes current viewer item. I know I'm trying to clean up that data. So maybe I finally did it. And that plot I need to get rid of too. Yes, I want to remove the plot. And what if I want to get rid of all the stuff that was in the console? Can I select it all? What do I do? How do I get rid of it? All this stuff from a previous session that I want to delete. And I don't know if I can just gather it all and then hit delete, but it doesn't seem to want me to delete it. Is that? Ah, that did it. Little broom there to clean up. Alright, so I'm doing City Bikes tutorial. And you get out of my face there. Move plot. Interesting. There's no clear thing. Maybe what you have to do is erase it from there. Clear all plots in history. Yes. Now it will disappear. I am sure. Or I was sure. I thought I was sure. I said clear it all from history. There we go. Right, so let's get back to where I was. So there's a path there. And anytime that you use a path in R, you've got to change your backslashes to forward slashes or it will not work. So if you're having a problem, that is why. So there's the path to the City Bikes tutorial and then to the folder and then to the actual CSV file. So I've got that in there. What am I doing with this? I'm following his tutorial and he says first to load the libraries for special features. So let's move this over here and let me bring this down. So my first line is to load the library, SF. I have to make sure always that I have the library. If you're on a different computer, you might not. So go to Packages and then look over here under SF. You should have it. I do. Simple features for R. So I'm okay there. So the library has to be loaded by putting in library. Then docs is an object that we're going to define. This is how you define it with the less than and the dash. It's defined as read R colon, let me see when we do it, read R. There it is, read R colon colon. And after the colon colon, then we can say read R, read underscore CSV. There's that. And then inside the bracket, it's telling us to read data. That data has to have single quotes and then comma and then our path here. So let me cut this and paste it there. And then we have to close the bracket here, so we have double brackets closed. And so what do we get? We get docs, looks identical, and then after the closed brackets, then we put in a pipe column, and then we put in a greater than sign, it looks like, and then we go underneath it and we say st as sf, and then it says under here as a comment which columns to use as coordinates. This guy's just letting us know that he always forgets long lat or lat long, and then he's saying coords equals c, longitude comma latitude, and then he's putting a comma after that, and then he says that we need to keep the coordinate columns, that's his comment, and then the move equals, and I guess that needs to be right bunched up there, remove equals false, and then a comma, and then projection system is going to be CRS defined as 4326, and then his close bracket. All right, so then he says,
but it's good for example. And the data came as a plain old CSV, latitude and longitude were stored as columns, so I need to read it in, then I need to convert it to an SF object. And I never remember, is it longitude then latitude or latitude and longitude? So I tried both ways and plot it and see if I'm in the middle of the ocean or see if I'm in New York City. And we set the CRS to be 4326 to tell it that we're using lat long. And this is what it looks like. It's an SF object, which is essentially a tibble with more information.
Well, let's see if we get that tibble that he talks about. So when we do that and we run docs to display what that looks like, and let me hit save here, we hope that we will get something equivalent to what he has. So let's run it, and it gave us an error. Unexpected. Okay, so what happened here? So let's go back to his screen and see if we can fix it. So we have docs identified as read r : read underscore CSV. Then there is a bracket, and then it goes to data, and then it goes to the location, and then black bracket and bracket. But this bracket seems to have no closing. Why? What does he have? He has a bracket here, and two brackets there. We have a bracket before data, but we don't have one before here. We don't have any here. We don't have any here at all. Here. Read SV, and then we needed to have another bracket that then said here. Oops, messed that up. Inside this bracket, I'm supposed to say here, and then I need colon here, and then my data. Here. All right. I don't know what that syntax is all about, but that's what he's suggesting. So let's select it all and run it and see if we get anything from there. Error. Doesn't exist. says that my city bike CSV doesn't exist. How is that possible? What if I put a single quote like that and make it a single quote in the back as he has, not that. All right. Let's try that. Let's see what that yields us. Still doesn't exist.
The system's actually much bigger now than it was when I pulled this data, so don't just go by this, but it's good for example. And the data came as a plain old CSV, latitude and longitude were stored as columns, so I need to read it in, then I need to convert it to an SF object.
All right, so this is where I'm going to have to turn to ChatGPT to help me and say what's wrong. Say thanks for your previous help. Always be polite to your ally. Can you detect what is wrong with this code? It says this .csv doesn't exist when I run it. And let me paste that code in. Incorrect use of here. It's designed to create relative paths within our project structure. You mix it with an absolute path, which is incorrect. Since we're already specifying the full path, just remove here. Alternative use here properly. Relative paths with here. Verifying file exists. Okay, file exists. The problem is something else. Possible reasons. The file's in a different directory. It's got a typo. Final fix. If you need to work in any R session, do this. Summary. Correct use. Try these fixes and let me know. Can you give me the full replacement code with your suggestions? Sure. Can do that. Sure. Final fix code. Oh, and it also loaded these two libraries, a read R, because that's something to call, and library here, which weren't in there. So that's good to know. Okay. So let's copy that. And then we can take this now and pop it in. And let's try that. Oh no. Error in X coordinates. This is going to be more difficult than I thought. Column specifications. So let's take a picture of this. And tell it I got these errors in X coordinates. And let's see what that shows us. Alright, so let's try the first thing it suggests. Let's come up here and I'm going to print this in, paste that, and then I'm just going to run this part of it and see what we get. So the actual column names are lat and lon, and we didn't have that. So coordinate C, okay. Fully corrected code. Let's do that. So we'll put this in, and we will run it. Okay, capacity 66 true. First few rows and comments, and so we do have a tibble now. Sample data, 816 columns, delimiter. All right, so at least we're getting somewhere. And then we do this print the first few rows and column names down here. All right, that's good to know. So we can go on back to our tutorial. All right.
Object. And I column, but it's a row. And 18 fields, that made sense that would be a column. We get a...
So if I do docs now, go in here and I want to see docs. Then I can just go to docs and I should be able to see something. So, docs. 816 features or 13 fields. Geometry type is point. Tibble. So what did he get? He got tibble is 813 by 19. This is 816 by 14. And then he has 66 true, false, DBL, LGL. He's getting some different stuff than us, but anyway, looks a little more promising.
Bounding box, which is the rectangle that fits all the data, and the geodetic CRS is WGS84, which is just lat long, which we already said earlier, they just use different names. Now, it's a tibble, so we're not seeing all the columns. So if I select just a few columns, the geometry column, whether it's called geometry or not, always gets selected along. It's sticky. So even though you can see I use a regular dplyr select, it included the geometry column for me. That's our station data. We also need New York City neighborhood data. And a lot of people think New York City neighborhoods can be controversial, like does Chelsea stop at 6th Avenue or 5th Avenue? There's debate. There is no debate. New York City tells us exactly where neighborhoods start and stop. They provide this as a GeoJSON file, which means that all the geometric information is already in there. We don't need to convert it to SF. We use the readsf function to read it in. This can read in shapefiles, GeoJSON, other files, even database connections.
All right, so we do want to get that data, and that means we're going to get NYC neighborhood tabulation areas. So NYC, wish my memory was strong enough to hold anything. NYC neighborhood tabulation areas. NYC neighborhood tabulation areas. All right. In open data and data set. How do you get the data set? Data set information. Where is your download button? Data type, columns, data set. Maybe you get the data here. So New York City. Borough, multi-polygon. So New York City. Can't find any data that matches that. All right, wait a minute. New York City neighborhood tabulation areas. Oh, there's that, but that doesn't give us any data. New York City open data. There's Brooklyn. So what are we going to use here? He wants us to use NYC neighborhood tabulation areas. Maybe I should type it in differently. I should go NYC and then dash neighborhood dash tabulation dash areas and see dot GeoJSON. Hey, buddy. I I did? Ah, let's do it from GitHub. There we go. That's what we want. All right.
Then you did something wrong.
Really?
Yes.
Download.
That's not playing.
And that's from him. This is Jared Lander. All right. So there's a GeoJSON zipped. And I guess if we go up.
Okay, I'm working in the rock.
There it is, but it's got to be unzipped, I guess. It doesn't look like it's zipped. Properties. Doesn't say. It's not file folder. Well, we can try it. We can take this out as a GeoJSON and cut it out of here. It would be in here. Oh, it is zipped in here. So let me extract all to here first. And now that I've extracted it, now I can take this and cut it and then go to my GIS, RStudio, and my City Bikes tutorial, and let's paste that in there. And then since I have that data, I should be able to go in here, and he says to do NYC is defined as read SF here, but I'm not going to use here. I'm going to use the full path so that other students could use it no matter where they store it. So I will go back into my City Bikes tutorial. I will grab the path. I will go into here and I will say NYC is there, and that's where we're pulling it from. Read, and I had mine now defined without the here. So I just put in, looks like you just put in the whole darn thing with quote. That's what seems to be rewritten. So read underscore SF. Is that what we're doing? No, just CSV. Oh, no, we're doing something else.
The rocket is aiming at you.
I see that. CVS path. CSV path. Oh, then I need to tell it. Right. So let me find out here. Stop it.
That was just the rocket, Daddy.
Great, thanks. How do I get this data in the program? Okay, stread. Find the path. Okay, just define the path like that, and forward slashes in it. So let's just then take this, and that way we can get that into the code, into the program. So we can get rid of this, not use the way he said to do it. We'll just All right, so I'm integrating this. So it's got that in it. So rather than having this in here as he does, I put that in. Let me see what this looks like if we run it. So here we get some Fresh Meadows, Borough Park, Queens. So that's the GeoJSON data. And multi-polygon.
This is a GeoJSON file, which means that all points on a map, here there are multi-polygons. A multi-polygon is when you can have two disjoint polygons.
And it's multi-polygon data, and it does say that it's multi-polygon.
That are one unit.
Yeah. So The next thing he says is that we should try to do plot on docs. And if we did that, we did a plot, then you see this data plotting, as he told us there. So that's really cool that we have successfully gotten that data in. Every single column seems to have a point, a multi-polygon associated with it based on points. So that conforms, it's all working out.
The geometry column, and then color codes it according to a specific column. And it makes a small multiple for free. You don't need to do anything cool. But if we just want a plain simple XY plot, we just selected the geometry column, and we get this dot matrix plot.
Okay, so this is what we want to get if we want just that. And so we could say docs. And then from there, oh, look at that. It actually pulled up the data table. Oh, I didn't realize it would do that, but that's a very cool feature. It brings up the data table and its geometry, this one here, that we're going to work with. So if I say docs, and then I bring in the pipe, and then greater than, so I'm not sure what that means, and then say select, and then geometry, and then come out here and give it a pipe, and then a greater than, and say plot, then supposedly when we run this, I do want to save this since it's working, but when we run just this part, yes, we get exactly what he saw there. I'm going to ask ChatGPT what this means. Just say, what is this syntax? What does that and it tells us it's called the native pipe operator. Cleaner, more readable way to pass the result of one function to another, similar to the greater percent pipe from the Magritter package. I used that in another tutorial that I had. Let's break it down. Docs passes docs to the next function, selects only the geometry column, and then plots the selected geometry. Plot selected docs geometry. Without that, it would be written that way, or using this pipe from the Greek, it would be that. Select geometry, plot. Key advantages: improves readability, left to right flow, easier to read. No need to load extra packages. Unlike this, the base R pipe does not require Magritter. That's nice to know. Encourages functional programming. Makes code more modular. When should you use it? When working with base functions, or use this other one when using Dippler or ggplot2 or tidyverse functions that rely on non-static evaluation. All right. Transform plot, so it's better in tidyverse workflows. It's the new base R pipe. Makes function chaining cleaner and more readable. And but this one you use for tidyverse workflows. All right. So good. So we got that, and then
Cool. Looks nice. You can tell it's Manhattan and Brooklyn and Queens and some other stuff we'll talk about. But let's say we want to plot this on top of our neighborhoods. Well, first we plot the neighborhoods by taking our NYC data, getting the geometry column, plotting it, and then we call plot on top of the docs, and we say add equals true.
Well, let's try that. So in here now, let's come in and let us see NYC, and there's the neighborhoods. So that's not docs, this is the NYC data, which has geometries. Borough Park, Murray Hill, okay, the codes. So the NYC is already in there, we loaded that, now we tell it to pass that through the pipe to select, and then geometry, and then go to send it to plot. So I did that, and I don't, oh yes, I say plot. But if I run this, then do anything. Then if I do docs, and then tell it to do the pipeline, pipeline thing they're talking about, and then select geometry, and then go and give it there and there, whoops, there and there, to plot with color equals blue, and then add equals true, and then close the bracket, color blue, oh, no bracket here. Okay, add equals true. So let's see if we do all of this. What do we get? Error, object, NYC not found. Object NYC not found. I thought we put NYC, oh, no, when we created it, we did something that ChatGPT told us. We didn't do this one here, the GeoJSON, we didn't tell it anything about what NYC was. So if we go back to here, we had docs.
Then I need to convert it to an S that fits all the data, and making is at longitude. The CR has to be 4320. It's essentially a Tibble. Feature is not a data. We also need to fix that. Don't need to convert it to S.
So NYC has to be defined as that. So I think what that means is I need to come in here and I have to say that NYC as an object is going to be defined as that GeoJSON path. And if that works, then when I run the whole thing, NYC error in use method select, no applicable method, select apply to an object of class. What does that mean? Character. So NYC So ChatGPT gave me this other thing, but if I say NYC equals and I get rid of GeoJSON path and I say oh, so I don't have to put GeoJSON path. Maybe NYC. Let's try this. Let's try to get rid of this. And let's say if file exists NYC, then we would read neighborhoods equals NYC. I hope I'm doing this right. And then print NYC neighborhoods. Let's just see what that does. No, it's still. I'm going to ask Chat what is wrong with this code. And then I'll put that in. Duplicate CSV reading. Oh, sorry, yes, their docs were wrong. Second read. Docs is not defined before. Try to plot docs, but there's no guarantee. Using column, docs will be no. Sure. After defining docs, confirm it's for plotting. Probably correct substance. Coordinates. Actual column names will be different. No, they're fine. Okay. NYC is plot won't work. The line Final fixed code. All right, let's try it again. Let's bring this up here, paste that in. We'll have something for us all to work with. And then we will select it and we will run it. Error, cast subset, columns. Got this. Oh, I thought we already went through this. We're good. We had latitude and longitude, and it was supposed to be lon and lat. So even without doing that, I think we know what the error is. This is lon and lat. So we adjusted that for the column names. Let's see. It's not giving us an error yet, but we have that one there that we had before. Let's see. Ah, look at that. So we have something there. That's looking better. We get rid of that. Clear the plots from the history. Let's rerun this and see what it gives us. Oh, it doesn't like this. Like, what is that? Unmatched opening bracket. There shouldn't be a bracket like there. If file exists. Okay, let's try it again. I think we're missing something in here. We're missing something, so maybe it didn't capture the whole thing. So let's say, just see the correct, put this in part of your code. This is supposed to be the whole correct code, fully correct code. Let's put this in again and let's paste that into here. Delete that and let's go from here. Print first few rows, print headbox. Why is that giving us? Now it's just sitting here. So I'm going to put this on pause. All right, a lot of troubleshooting later. When I run the code now, I do get I get these plots, so that's good. That's nice to see. But when I try to merge them, I get this way off here. So it looks like they're misprojected. So I want to make sure that NYC neighborhood is also using that. So check the coordinate system. I guess you can just copy that, and then I guess I could just run this down here instead of going into my code, and then try it out. And then it says WGS84 and EPS. So now it is the right one. So I'll tell it that, and then everything about it is So we have to say to it, they're not different. Full fixed code. And I could put in. Hey, here's what I'm going to do. I'm going to save this. And then I'm going to go in and grab what they call the fully fixed code and see if it does better. So I'll select all of this and delete it, and then I'll pop that in and try to run it all. And we get that same problem. That problem we had when we were using lat lon, because it's called lon and lat. So let's change that to lon and change this to lat. Now let's try it again. And now it matched. Okay, so we zoom in. It's way over, that's tiny, but it works. Okay, so we do get all that. I'll just scrub all these plots from history and run it again, just to see what we're producing. And it centers there. That's all it gives us. Okay. If we erase all of that, run it again, I want to see what error messages we get. It says New York City neighborhoods file not found. But it is found. It's there. Well, oh no, that's a else. That's part of the program. And it's saying if else, then say stop. But that's not what happened. So we're okay. Everything looks good. Right, so let's save that. And then let's go back to our tutorial.
Manhattan and Brooklyn and Queens, NYC data, getting the geometry column, plotting it. And then we call plot on top of the docs, and we say add equals true. This is base graphics that's adding a layer on top of the previous existing plot. And we're just setting the color to be blue. And you can see all these dots across the Hudson River, that's Jersey City, because they expanded the program a few years ago into Jersey. We could do more base plotting, but we won't, because we'll turn straight to ggplot, the old standby that can plot anything. So first up, we're just going to plot the dots. And we see here we call ggplot, give it the SF object, then we say geom SF.
So with this, then, yeah, okay. I mean, we could get that, but we can also come in here at the bottom of the code and then add it. And I'll say, oh, the library should always be in there on top. So let's go up to the library. We can have a lot of libraries loaded. And we'll say library ggplot2. And then you want to go docs. So that's after the stat's been loaded. So let's go down to the bottom here and go ggplot. And then go docs plus, right? Let's say plus. And then the next line, we want geom underscore SF. And then plus. And that's supposed to be a space. Yeah, maybe a space there and a space there. And then here, coord underscore SF. All right. And let's see if we just were to plot that, we were to run that. So let's make this bigger and say run. Error, could not find function ggplot. Maybe it's because it's supposed to be ggplot2 and he wrote it wrong. You can always find out by doing that. Could not find function ggplot. Okay, so let's Control Z on that. And let's see. Even though we've loaded it, because we didn't load it up here. So you'd have to run this to load the library. And then you run it. That's it. Okay. That's what it was. You got to run these different sections. That's a different way of thinking. All right, good. Well, that's consistent. And we'll now save that. And let's move this and see what else we got here.
it automatically knows, go to the geometry column and plot whatever it is. If it's points, draw points. If it's a polygon, draw polygons. It does it all automatically. And I'm using chord SF just to make the boundaries look right. And you can vaguely make out New York City here. But I want to plot this on top of the neighborhoods like I just did. So we're going to just add another layer here, and we will say geom SF twice. The first time we say data equals NYC data, that gives us the neighborhoods, the polygons. And the second time we say geom SF, which uses the default docs from the ggplot call. Now it's a lot nicer, but it does still look like it's from the 80s.
Okay, well, I'd accept that for a moment. So geom SF and that one. So let's bring in another line here, and let's say geom underscore SF, and then inside it put data equals NYC. I wonder if we're going to need to put NYC neighborhoods in ours. We'll have to see. So let's try this, and let's see what happens. And it's error. Must be in a data frame in Fortify. What the heck does that mean? SF data equals NYC. Let's change this plus out there. Let's try it now. And caused by error. So what's he saying?
We will fix that in a little bit, but before we can fix that, we have to answer the question, how many dots are in each neighborhood? Data equals NYC data, that gives us the neighborhoods, the polygons. And the second time...
So we got some problems here. Data equals NYC. Maybe we shouldn't put in NYC. Maybe we should put in NYC neighborhoods. And we'll try to run it. That is what we needed. In ours, it's NYC neighborhoods, unlike his. All right, good. Let's save that, and let's go back.
Time we say geom SF, which uses the default docs from the ggplot call. Now it's a lot nicer, but it does still look like it's from the 80s. We will fix that in a little bit, but before we can fix that, we have to answer the question, how many dots are in each neighborhood? This has many steps to it. We first need to do a spatial join to figure out which dots are in which neighborhoods. We then need to just compute a count of each neighborhood, and then create a plot, which is a choropleth. So first, the spatial join, which dots are in which neighborhoods. So we take the docs data frame, we select a couple columns out of there, and then we ST join it into the NYC dataset. This is a special type of join. It is when one of the row of the left table matches one row of the right table based on a spatial relationship. We can define that spatial relationship with the join column. Here I'm using ST intersects, which is sort of a catch-all. If the point is touching the polygon, if the point is overlapping the polygon, if the point is crossing the polygon, if there's any sort of like physical relationship with them, it captures it. And I'm doing left equals false, because I don't want a left join, I want an inner join, so I'm only getting dots that are represented in New York City neighborhoods to get rid of all the ones in Jersey. So this is what it looks like. Since we joined it on the docs data frame on the left, we have the geometry points from there. And you can see we now have each neighborhood each doc is in. So now I want to do a count, so I just use regular dplyr code, and I first drop the geometry because things go faster. So this is what it looks like. Since we joined it, like the point is overlapping the polygon.
And we'll just go and copy it in, because that's how I learned. All right, so let's move this down and say docs underscore in underscore neighborhoods is defined as, we're going to define that object as docs, but then with a pipe to, and then a comment, only care about the station name and geometry. And we say select, which we have from declare, station name, geometry, those two columns, and then the pipe to. Now we're going to do a spatial join, and that is st join, open bracket, and then it's telling us that in a comment only need these columns from neighborhood tib, whatever they call that thing, tibble, and then tibble is NYC. Oh, but it's neighborhoods every time. Don't want to make that mistake. NYC is piped to select borrow name, Natan name, and geometry, and then put in a comma, and then a comment that says join rows where there is some overlap between comment a dock and a neighborhood. This is a fundamental GIS thing, knowing how to do spatial joins. So the join equals st underscore intersects. And then there. Then keep only docks that are in a neighborhood. This will ignore Jersey City. And then they go left equals false. And then we close the bracket. That bracket there. When he runs that,
the point is crossing the polygon, is if there's any sort of like physical relationship with them, it captures it. And I'm doing left equals false because I don't want a left join, I want an inner join. So I'm only getting dots that are represented in New York City neighborhoods to get rid of all the ones in Jersey. So this is what it looks like.
So that's what it's supposed to look like. Let's save this. Let's see if we get anything like that. So when we do docs neighborhood and we run, it says can't select, station name doesn't exist. Columns that don't exist. What if we run the whole thing? No. Can't select columns that don't exist. Station name doesn't exist. Okay. Something's wrong. Select station name. Station name. So if we were to ask it, when we go down here and we say docs, then you see, let's see where the station name comes in.
With them, it captures it. And I'm doing left equals false because I don't want
Station name. How do I know what that is, station name? It's telling us error in select. Column station name doesn't exist. Run rlang last trace. So the trace station name stat ion name doesn't exist. All right, go back to chat. When I run, oh, you know, it could be. Maybe I need to run the whole darn thing because maybe it's not picking it up from the top. Before I make any mistakes there, let's see what happens. No, it still says station name doesn't exist. Alright, so if station name doesn't exist, I'm just going to take this picture and put it in. And dataset docs is not containing name. Perfect. So check the actual name in docs. Print names docs. Alright. So let's go and look at this. And once again, we come down here. If we don't want it in the code, we just hit that. Alright, station name, station ID. That's what it is. Maybe. Name, or it's just name. Alright, so let's just go back here and say name. Name geometry. And then let's try this. Run. No applicable method for ST interacts. Error in use method. Right there, join equals ST interact intersects. No applicable method. Object of class null. Let's see what it says. Check if my synchronization geometry. Yeah. Or maybe it's not supposed to be NYC neighborhoods. Maybe it's supposed to be NYC. I think I put that in. So let's try that.
Yes. No, it's on it down. Sun is down. Cannot watch tomorrow. If you turn it on, you will not watch tomorrow. Stop. Sun is down.
I changed NYC neighborhood NYC, and now the error is this. Yes, I never defined NYC in here, so if I go maybe I should put this in here. What's the matter, Nari? And then let's see if we run this. ST intersects. Still turning null. Neighborhoods, let's try that maybe. I really don't know what to do. No. So let's take a screenshot. And let's look at this. let's try this under here. Multi-polygon, okay. Does have geometry. Alright. It's not null. Let's try this. See if they have the same geometry. One of them, and the other one is docks 4326, and actually neighborhoods is 4326. So it's not that. And then Dr. Neighborhood. So what is it doing? I need to go and pause. Alright, so I got this code from ChatGPT and pasted it in after my ggplot docs, and this is to get the docs in the neighborhoods, and then you can see that it did in fact make that tibble. So it does appear to have worked. The plot is still the same, so having that, and never quite understanding exactly what I'm doing, but then when we go to here,
I want a left join, I want an inner join, so you can see we now have each neighborhood each doc is in. So now I want to do a count, so I just use
docs and neighborhoods, and so we did get that. We got docs and neighborhoods right there, and we see it here. Docs and neighborhoods printed. I'm going to pause now. All right, so now I've gone to this part here because I do see that we did print out those joins. So now we have this other count by neighborhood that the guy wants us to do, and so if I take that and run it, it says there's an error. No applicable as ST as SF.
You know what will happen when the bomb
Now this could be one of those things where we have to go to the top again. So to check that, I'm going to just run it from the top again and see what happens when we do that. But it's still saying that. All right. So
the bomb just landed.
I see that.
And look at it. It's gonna keep multiplying.
Okay, keep multiplying. That's not necessarily a good thing. See what he says to wrap it up.
He actually
the bomb is gonna get
faster, then I just do count of the neighborhood name, and then I right join it back into the MIC data, so I can have this count column joined in with the polygon data. And we see it right here, we see that there are 22 dots.
Yes.
I didn't say something else when the
Okay, so they gave us an error, and to test that error, ChatGPT is suggesting we run this to make sure it's not null. And it has things. Okay, so check if docs has NTA names. So when we look at it, we have NTA name. Yes, we do. Okay. And then it says if it's missing, that didn't work, ensure as joined, have the name column. And then it's missing, check if NYC has NTA name. So let's try that.
Everything that's all red is fine.
Yes, it does. All right.
Everything that's all red is lava and lava centipedes. And lava centipedes are centipedes that are red. Say, look.
Yeah.
Say, look.
Right.
Look, I just caught a lava Abby. Daddy!
Yeah.
Like, this is
So we do have
I love
in the test join, it's not null. So that's good.
Lava.
And then
Because I like lava.
one didn't
but
fail.
I don't like lava more than water. So that's why I'm gonna build a water section. So I don't like the water section. Did I just hear you
So maybe if I copy this code, print names, prints NYC, correct name, just if needed, count by neighborhood, ST as SF, unless I wrote something, no, it's ST as SF. So maybe what I need to do is come into where it says print docs and neighborhoods, and then print count by neighborhoods. I don't know. ST drop count by neighborhood is there. Correct name. Ensure names. So if we take this part and this part, and then we do the count by neighborhood and then print the results, and replace that with, because we printed the doc in neighborhoods, but we haven't gone through there. So maybe we paste that in. So we have print names, print docs and neighborhoods. Try this again.
The invisible bare wall is right here now.
Okay, well that seemed to work. So, so the counting neighborhoods is there. And we see Astoria, 22, Queens. So there's more now than there used to be. Same in Battery Park. All right, so
In Astoria, 23 in Battery Park, 21 in Bedford, so on and so forth. It's one row per neighborhood. So let's plot it with ggplot. We call yet again geom_sf, but this.
Right, so then if I'm getting this right, then when after we do our print counts, we go and we put in ggplot and then put count by neighborhood, and then AES ill equals n, and then add to that geom underscore SF, and then add to that coord underscore SF, and then, oops, so let me pull this back, and
that has a count column.
so that's supposed to work. Save that. So we've just added this on there, so let's go and rerun everything, as is our habit, and see if it produces anything. A session aborted, a fatal error. Well, I'm glad we saved that, because that crashed R in a serious way. Alright, so is that where we were? It must be. Geom and coordinate. Yeah, we can try it. Hope it doesn't crash. Ah, something printed. Ah, there we go. Look at that. So that's working. That's sweet. So now when we go back and look at this.
And we say AES fill equals n, the count column, and it colors it for us. Jersey City is gone, and we see that lighter blue means more dots. That's awesome. But I want to move on to other ways to map, and we have two more methods. The first is going to be tmap. We're getting a little fancier here. With tmap, you pass the SF object to tm shape. That defines the layer that you'll be working with, and since I want to draw dots, I then call TM dots, and this plots the geometry column as dots. If I want the neighborhoods, I call TM shape of the neighborhood dataset, and then TM polygons. I then change the layer with TM shape again to use docs, and plot TM dots to get the dots on top of the polygons. You build it up iteratively, much like ggplot. And if you want a choropleth, you do TM shape of another data frame, and you again do TM polygons, but you say call for color equals the column n in quotes. Map, and we have two more methods. The first is going to be tmap. We're getting a little fancier here. With tmap, you pass the...
All right, so I need to make sure I've got the library for tmap in here, and I don't. So let me put that up there. Library, and then tmap. All right. Now, since we have tmap, after we've plotted all that, I'm getting the hang of this. You can keep putting in various commands to plot stuff over and over. So once we have that, we will come in here and we will say tmap underscore shape and then put in docs, and then we will put plus and then tm underscore docs, and then that. And if we run that with the other stuff that's been preloaded, so I think we just select this and run it. Nothing happened. It couldn't find the function tm shape, and that is because we didn't go and run it from the top. So let's rerun it from here. I also could have put the library down there to save myself some time, but this will be interesting to see because it'll plot each of the things along the way. As you can see, it's plotting and then plotting, and there we go. All right, so that worked. And we got that, and then we...
The SF object to TM shape. That defines the layer that you'll be working with, and since I want to draw dots, I then call TM dots, and this plots the geometry column as dots. If I want the neighborhoods, I call TM shape of the neighborhood dataset.
Okay, so we're going to do that now, and we are going to do the TM shape of NYC. Plus, and then we'll do TM polygons, and come over and add to TM shape, and that shape is going to be docs, and then TM dots, and then that. Alright, so when we run that, because TM has already been loaded, we should be able to just run it from here without error, and then yeah, we get exactly what he showed there with the dots on top of the shape of the docs. Looks like whatever is last is the one that's on the top layer, which is interesting. So next thing,
and then TM polygons. I then change the layer with TM shape again to use docs, and plot TM dots to get the dots on top of the polygons. You build it up iteratively, much like ggplot. And if you want a choropleth, you do TM shape of another data frame, and you again do TM polygons, but you say call for color equals the column n in quotes, and that color is in for you.
Okay. So we'll do TM underscore shape, and then we will say count by neighborhood. There it is, which we defined earlier, and then TM underscore polygons, and make it call equals n. And we can run that and see what we get. Well, it's not pretty. doesn't have those colors. Maybe my data is not distributed that way. What do we have? We have name, column N. You don't see a column N. What is the column N? This is lat, lon, has, kiosk. We're talking about count by neighborhood. So how did we do that? How did we list the data so we can see it? We have print names, and we would be count by neighborhood to see what that would be. So if I say print names, and if I go down here and tell it to print names, but instead of New York City neighborhoods, let's get this count by neighborhood. Let's see what that returns. N. Well, there is an N. Yes, there certainly is. N. Geometry, shape, length. I suppose we could use a different one. I wonder if, is it possible that this, no, it's got to be that. Well, what if we do it by the NATA code, NTA code? Let's see if that changes anything. And try that. Wow, a lot of different colors there. So if we do it by the NTA code, what if we do it by the object ID? Not as fun. What if we do it by the NTA name? Oh, and then it gives all these different names for the different things. That's kind of cool. Because you get all the data in there. What is he seeing here? He's got nothing. Oh, he's got 1 to 5, 6 to 10 when they use N. Ours didn't do that, as I recall. Ours, when we run it, ours gives us 0 to 5, 5 to 10. It's just they're not pretty. So for some reason, we're not getting, the color is N, but it might be the way that the layer is laid on. If we were to, no, it's showing what it wants there. So it's not filling in. I'm going to ask ChatGPT about this. Oh, and before I do, let me go and get to this here. Alright, so we'll take this and put it into chat. And then we'll take a screenshot of what he has. We will say, why are my colors so much different and unfilled than the YouTube tutorial? And see what we get from there. Causes the color scale is set to default style. Fills the map with light blues.
What is the game that Squirtle was in again?
Alright, so it seems according to chat that I need to use the same color scheme because it's using a default color palette blue. and that fills it with light blue shades. So we want to use yellow, orange, red. Orange, red. So when we go to TM shape, then we want to, after TM shape, put in the polygons, but put in a different palette. So let's go here to TM polygons, put both of these things in. Put that in, and then let's try that and see if that does anything interesting. Yes, it did. All right, so that's good. Chat also gave us a suggestion that missing values aren't handled correctly. So fix a specific color for missing data. So if text is not applicable and it's no data, then use gray 80. And then you can go like that and put this instead in. So really building up the different parameters that you want. And then let's run this. Yeah, which is great. I mean, I could have changed it to data. I could go in from gray 80 and I could say, let's see, if I were to make the no data ones blue and then run it, then I would still have to come up here, I guess, and run it. Yeah, and then it comes blue, but gray 80 is fine. And then we can take that back to gray 80. So it's nice that you have that capacity for the non-applicable areas. And then it appears that it's telling us we can do a different color scale, the binning of the color, differences in station density. So we could do breaks like this after yellow, orange, and red. Hold on. So the whole thing would be this, and we would take this out and see what happens when we run this, and we'll get different breaks. But that's fine, manual binning. Alright, so that's nice. Let's pause here for a moment. Okay, so the next thing that he shows is using leaflet. And
mapping package leaflet.
okay, let's see if
TM plot can do interactive, but leaflet excels at it. I'm a much bigger fan of leaflet. So if leaflet, you say leaflet, and here I'm giving an element ID. You don't need to do that interactively, but if you're using R Markdown, it makes things a lot better.
Let's go to the library again.
It's still inside the book that Daddy gave me. And there's also command in that book.
Element
Mike, do you know what
equals
the strongest is the enemy ever? It's a river.
That is drawing from or going to.
Yes. The river storms are super big. They're the biggest enemies ever. And they shoot and they attack by shooting giant pieces of
it goes to add
that blows you up.
and data.
When you get caught in the explosion, you only take a little bit.
Then when we run this, you'll notice it does not happen in the plots window now because leaflet is going to be in the viewer.
What happens when you put food
not find function edge was odd because we didn't run it from the top. So here's where temporarily, instead of going up to the top, I'm just going to go to library and that in. And when I run it, it should know what to do.
On the grill, Mommy. Do you burn food on grill? No.
So
What do you do?
this is built under a different version.
When do you do it? Okay. The only thing that we can do with the grills is burn them.
There we go. Okay. So under viewer, subtoolbox is just what we did before, but leaflet is all of this. This interactive open street map showing all the data represented, and that data is docs data from the element type docs. Doesn't seem like you can do anything in here, but at least you have this map, as he said. So there's more that he wants to tell us we can do.
I say add tiles, and that gives me this background, the base plot. It looks like...
Okay, so we're going to continue to add to the code here. And so if we go to add polygons, let's come in here and add polygons. And then in here we say the data equals NYC. And then the data color equals black. Yes, Nye. Yes, Nye. Yes, Nye. And then weight equals 3. Yes, Nye. Okay, hold on. Opacity equals 0.2. And then pop. Yes, Nye. So you can see I added the things that he's asked for here, which includes something called a pop-up. And I'll see how this works with it. It's going to be interesting to see if we run station name not found. I thought we had that problem before where there is no station name. Name, geography. I think there was a problem. It said there was no station name. I wonder if you can look through it. Can you do Control F? Yeah. Station name. No more occurrences. Previous text. Huh. That station name. What did we change it to? I think we were talking to ChatGPT about that. You know, remember. And you can't do a search with ChatGPT as far as I know. So MTA name missing. Somewhere in here we had a problem with station names, I recall. But there was a code that we ran to get names, and it was print correct names. So is there a station name? What was it? So maybe I can look through here, because I think we saw an error down here. So maybe if I do a Control F and I say station, that's there. Go to the next one. City bike stations. Stations not found. But it doesn't let me look for anything in here, which is dreadful. So station name.
And you can see here I added an argument, pop-up.
Pop-up, yeah.
Equals tilde and T name. If you click on a polygon, it pops up with the neighborhood name. Same with the circles. If you click a circle, it pops up the station name. You do tilde, bare column name.
All right, so that would be fun if we could get it to work, but what did we use for the station name before? If we let's see, we print names, we had something there. Where was that? If file exists, print names, print available columns to verify names, print names doc. Let's try that again. Just run just that one line. Rerun the previous code region. Okay, so it looks like it's just name. So maybe we just come down here and change this to name with a small n, and then let's save this and run it. And then pop-up name stuff has been run. Yeah, there we go. So Pershing Square North, Life in Bedford. So now we do have these pop-up names for each of these stations. Park Cemetery, Park Cemetery. So it looks like some of the polygons work. It turns into a little finger when there's something to do. Ridgewood, Ridgewood, Brunswick North, Park Cemetery, Queens. So that's pretty cool. So that's what the New York City polygons data in a light black with an opacity of 0.2, and that's the NTA name that they have there. But when you go to a point, you get the stations. Pretty darn cool. I like that. Let's see now.
So the problem with using Leaflet generally is that it doesn't scale to large data. So we have LeafGL. This uses WebGL. And when you do that, you can plot hundreds of thousands of points in a few seconds. Here, I did the same thing instead of add polygons, I did add GL polygons. Now the problem with add GL polygons, it doesn't like multi-polygons. So you need to cast it into a regular polygon first. And now when you do the pop-up, there's no consistency. You no longer do tilde column name, you give the column name in quotes, because different people wrote different packages and they have no consistency. But it's nice, it gets the job done. Let's go ahead and plot a choropleth.
So let me see if this will work. So we'll come back to here. Oopsie. And I don't know how much you can run in this. That pop-up name. So there's another library we put in. This time I'll just put it in down here at the bottom and call it LeafGL. High performance 1. And then from LeafGL we'll go leaflet element ID equals docs hood GL. I'm not sure where that's supposed to come from. It might be in the data set. I don't know. Get error messages if it doesn't. So that one. And then we do add tiles. And in there we don't have anything. So we just have the pipe. And then we have add GL polygons. That is one of the commands. We get that. And we say data equals NYC. And we keep the pipeline. And then from there go to stcast. And then polygon capital. And then we have a pop-up equals NT, it needs a quote, NTA name, and then it says to do the fill color equals black, and then I guess it closes the, make sure that that closes right. Where is it? Yeah, suppose is okay. And then, I don't know if we're supposed to hit plus on this or not, or is it just a pipe? It looks like these are all pipes, so let's put in that, even though we can't see it there, we will have to take it out. And then add GL points, and in there it's data equals docs, and then pop up equals name, because there's no station name. We found out. Alright, so let's see what this does if we run it. And we plot it. Ooh, okay. That was pretty cool. But I don't see any pop. All the pop-ups, I guess, do occur. But it stays a hand. Pain point. And that's for filling in with the black color there. And then the data docs and the pop-up is still the name. So I don't know why he likes that better. I guess he says it uses more, can do more data with it. So that's fine. And
if I use regular leaflet, I have to first create a color palette by mapping it to the domain of the counts, and then I have to call add polygons and say fill color. It's a whole thing. I don't like it. It's a huge pain. I'm just going to skip this slide and move on to a better slide, okay? Before I get into the better thing, though, I said, well, maybe I could zoom in on the plot. And you zoom in by saying set view. I say set view, give it the center of the view with longitude and latitude, and I set my zoom at 11. The default is 10. It can go from 1 to 15. This is a little bit easier to read, but it's still hard to read that choropleth, right? It's hard to make out the colors. It's a little too busy. So I thought, well, let's change the base map. By changing the base map from OpenStreetMaps to CartoDB Voyager, it's a little simpler. The background is a little plainer. And the way I did that was I switched from add tiles to add provider tiles. Now, the version of Leaflet on CRAN does not work with Quarto. So I had to go make...
So this is where we're going to end for now. There's so much more that needs to be done, that can be done. And he gets into different types of maps and ways of doing different colors. And this is only halfway through his tutorial, so that's where we will end. And so we're going to end here and wish you a very